All right, good afternoon, students. How are you all? I hope you all good. And anyhow, I hope you all good. But I'm not finding here saying good morning, good afternoon. Nothing was there today. Yes, Akshit, good afternoon, so everyone. And today we will try to complete. Yes, what's our internet is finished so that anytime I can leave the class and see offline classes. Satish, you should take care, man, beginning itself. I'll write Priyanshi, good afternoon, right? Next, where is remaining? So 3 members are present now. Shubham, good afternoon. Yes, 4 members and 2 are mine then. So 4 are present. Where are remaining? Himanshu, Kiran, and Trapti. Okay, Jinisha is what we done that mistake and we'll complete that part. No, Google to full taking internet now, consuming less and more benefits now. All right, I'll wait 1 minute after that. So I'll start our class. Okay. So if we start our class fastly and we will complete fastly. Once if there are 13 members, then we can start. All right. Let me start. Then we'll see next. So now we are starting this example number. Which one I was not explained for you? Yesterday, example number 12, I think. 12 or 13? 13. Example number 13. F of x is equal to e power minus 1 upon x square into sine 1 upon x if x is not equal to 0. Another one 0 if x is equal to 0. Right. Before going to our class, just close our eyes. Then we can start praying. And then in this prayer, after this prayer, 1 minute we need to be silent for. I listened about people. Grandmother was no more, so everyone need to be 1 minute be silent so that the peace be with on their family. Okay, right. Let close your eyes. God, kindly provide your knowledge and wisdom to us. Thank you, God. Now, 1 minute, we will be silent for the peace of Deepal's grandmother soul and then comfort of Deepal family. Okay, let's close your eyes. Right. All right. Now we will start our class. This 13th one, f of x is equal to e to the power of minus 1 upon x square into sine x if x is not equal to 0 and 0 if x is equal to 0. Actually, one definition I was missed to tell to you all. What is a differentiation means? For the all the values of domain, if it is a differentiable, then we can say that it is differentiable. Okay, what is differentiable means? So for all the whichever the domain values. So all for all the domain values, it need to be the continuous. Okay, then we can say that it is a differentiation, or we can say that all the derivative of the each and every point in the domain is satisfied. Then we can say that it is a differentiable. Okay, anyhow, we'll discuss here now why I was explaining that those are. And here no need to remember sine x upon x formula. Directly remember only e power x formula here. So what is e power x? You already know that 1 plus 1 upon x, 1 plus x plus x square upon 2 factorial plus x cube upon 3 factorial plus and so on. This is about your formula. You just remember that formula. Okay, right. So I think Kirtan also present now. Where is Trapti? Trapti is not present. It is right that our education system is changed. Akshit, these all you can ask me later. Now, let me finish this part. Last 5 to 10 minutes, I'll discuss with you all about this. Okay, right. So now f of x is equal to e power minus 1 upon x square into sine 1 upon x if x is not equal to 0 and equal to 0 if x is equal to 0. So now at x is equal to 0, we have to find. So first f of 0 is equal to, already they given here if x is equal to equation number 1. Now we go for left hand derivative. Left hand derivative means what do you know? That is limit h tends to 0. Here already you know that f of a minus h. A means what do you know here? 0. So now I can write f of 0 minus h minus f of 0 upon minus h. Now what I'll do here, it is limit h tends to 0. F of 0 minus h means minus h. So this minus h you have to substitute in the x place. Okay. So then what will write? E power minus 1 upon x means minus h whole square. Next into sine 1 upon minus h. So after that, here what is symbol? Minus. Just write symbol minus. F of 0 means what you found here? 0. Just substitute 0 upon. Here minus h is there, right as it is, minus h. So then what we need to do? This is equal to limit h tends to 0 e power minus 1 upon minus h square means plus h square. So 1 upon h square into sine. So here it is minus 1 upon h. So what I can write is minus 1 upon h. We can write as minus sine 1 upon h. Because you already know that sine of minus theta is equal to minus sine theta. So I applied that formula. Then I got here sine minus 1 upon h means we can write minus sine 1 upon h. Okay, cleared up to here. That's okay. You all understanding up to here? Any doubt? I think no doubt up to here. Then after that, if you are remove that 0 as it is, we written upon your minus h is there as it is minus h, right? Minus minus get cancel. So then what we can write here? If minus minus is cancelled, then what we will write? So after that, what we are going to write is e power minus this is there. This we can think as a power minus m. So if anything a power minus m, we can write it as 1 upon a power m. So now what I'll think e as a and then minus m plus here it is 1 upon h square. So how can I write now this? This we can write as limit h tends to 0 e, this we can write it as upon 1 upon e power 1 upon h square. Here now this 1 upon e power 1 upon h square I was written by using this formula. After that, into, so this 1 into sine 1 upon h, and here already in the denominator h is there, that h into limit h tends to 0 sine 1 upon h, as it is, right? Sine 1 upon h upon e power 1 upon h square is nothing but it is just like e power x. So e power x formula, what I said for you. So here I'll write again, observe carefully. E power x is equal to 1 plus x plus 1 upon, sorry, x square upon 2 factorial plus x cube upon 3 factorial plus and so on. Okay, or 1 upon h square is there. So x place I need to substitute 1 upon h square. Okay, you are understanding, right? Okay, so now here it is, we can write here 1 plus 1 upon h square plus, then we can write x square whole square means we can write 1 upon h power 4 x 2 factorial plus and so on into h. So into h is here. Send this h inside, then you multiply each and every term with h. So what will happen? On h into 1 h. H upon h power 4, then you can write 1 upon h cube 2 factorial plus and so on. Up to here, any doubt? Anyone having any doubt up to here? I hope you all understood now clearly with the formula. Any doubt? No doubt, sir. Shubham. Okay. So now I'll go for my part. Okay. Wherever h is there, substitute 0. When you substitute sine 1 upon 0 upon, then here 0 plus 1 upon 0 plus 1 upon 0 into 2 factorial plus and so on. So you already know that 1 upon 0 means infinite. So now you can write sine infinite upon, here 0 is there and 1 upon 0, again here 0 plus infinite plus again infinite plus and so on. There are many infinites, we can write it as total together as infinite. So sine infinite upon infinite. And listen this carefully, everyone. See here it is sine infinite upon infinite. Sine infinite is not at all possible. It is an incorrect mathematical expression. But what is according to definition? All the domain need to be divided. So we know that this infinite value, the sine value should be in between -1, 1. In this domain only we have to take. So that was the reason what we are taking here. It is we are taking instead of sine infinite -1, 1. So when you take -1, 1, so then -1 upon infinite 0 plus 1 upon infinite 0. That was the reason we are going to write here as 0. Now clearly understood why it is becomes as 0. So here it is sine infinite. Actually, it is undefined, but it is in that interval. That is, we can say that domain value of that is -1, 1. So if that is -1, 1 is there, then what we need to do is, so in these numbers only we have to consider our resultant. That's what we will take -1 upon infinite or 1 upon infinite. Not only sine infinite, cos infinite comes also. That time you can use -1, 1 only. Okay. So that is about how it came as 0. So now left hand limit completed. Now we'll go for right hand limit. So now I will solve here right hand limit. Let me have this part. Right. So now RHD, right hand limit, that is limit h tends to 0. Here f of a plus h. A means what do you know? 0. So that f of 0 plus h. Then minus f of 0 upon h. This is your formula. Now f of 0 plus h means f of h. Wherever x is there, substitute h. So then what we'll get here? E power minus 1 upon h square. And the one into sine 1 upon h. That is upon. So here minus symbol, minus f of 0 means 0 upon h. And here it is your limit, h tends to 0. Again same, here see, if you are subtracted with 0, you get a 0 only. So now limit upon h upon, here we can write it as h into e power 1 upon h square. Observe this and previously which you solved expanded, those are that, again no need to write here expanding and everything. Directly you can write since from equation 2. So which is answered previously you got, that is equation number 2. So from equation 2 you can write limit tends to 0 sine 1 upon h into e 1 upon h square is equal to 0. Directly you can write, because in the equation number second also we solved and we expanded everything. So one time we need to expand enough. Second time no need to expand. Directly you need to write in since limit h tends to 0 sine 1 upon h into e power 1 upon h square is equal to 0. And directly we can write here 0. That is equation number, here equation number 2, and this is equation number 3. So at last, therefore, from 2 and 3, LHD is equal to RHD. LHD means left hand. Okay. I think you are not able to find this. Okay, little bit. Hand derivative. So that these both are equal means it is differentiable at x is equal to 0. So at last we can write, therefore f of x is differentiable at x is equal to 0. So you need to write in this way. I hope you all understood what to do, what not to do in this. Here main important concept here it is, you need to remember left hand derivative and right hand derivative formulas. So when x is equal to 2, x is equal to 1, when they are given, you just substitute in this a place that value. After substitution of value, if you get LHD is equal to RHD, both are, we can say that, differentiable, otherwise it is not differentiable. Okay, I hope you all understood. Can I move for another one now? I said Priyanshi, no. Okay, I will give at last one good news for you all. Don't worry, okay, Priyanshi. Now, not possible to give that, okay? But I'll try to leave you all early if possible. That is, if that 13 members need to come, but still 10 members only, it is fluctuating 10 and 9. So if 13 members are is there continuously, then definitely I'm going to leave you as early as possible. Okay, right? I don't know. I'm not giving any session for you last time. Yesterday I was informed to you this, it may be holiday. It is not clearly ever said. We need to wait for official confirmation. Then I will say. So till now there is no official confirmation. So I will tell to you if it is there. Okay. But tomorrow is holiday. 100% tomorrow is holiday. Okay. But Monday I'm going to tell a last moment of this class. Okay. All right. So now we'll go for our exercise number 6.1. Part-1. Right. So exercise 6.2, first question. Show that following functions are differentiable at x. First one, identity function f of x is equal to x. Okay, so they were not mentioned for you at which value it is going to be continuous. You need to take any value and you have to prove that it is continuous. Okay, 11 reached. I think still two more left. The two more. You are enjoying. Okay, enjoy. Right now, observe identity function f of x is equal to x is given. So then what we need to do here? So we don't know at which value we need to think. So that let at x is equal to a, it is continuous. So we need to prove that at x is equal to a, whether it is continuous or not. So I may think like continuity. Not continuity, it is differentiable. Differentiability. Okay. So we need to continue at differentiability. How to test it is first at a. So f of a means what you get? Wherever x is there, substitute a. So f of a is equal to a. Equation number 1. Now directly go for LHD. LHD is equal to limit h tends to 0 f of a minus h minus f of a upon minus h. Now wherever x is there, I need to substitute a minus h. So now here x is there, so f of x means x, so you need to substitute a minus h. So now we can write limit h tends to 0 a minus h minus what is f of a you got here? A. So substitute a, okay, upon minus h plus a minus a get cancelled. Then limit h tends to 0 minus h upon minus h both get cancelled. 1 limit h tends to 0 1 means you get as 1. That is equation number 2. Cleared up to here? Okay, we'll try. If it is completed, you will be happy. So now RHD limit h tends to 0 f of a plus h minus f of a upon plus h. So now wherever x is there, I need to substitute a plus h because here a plus h. So now substitute a plus h minus what is f of a? A is there. So that just substitute a upon h limit h tends to 0. A minus a plus a get cancelled. Limit h tends to 0. H upon h. H upon h means 1. So limit h tends to 0, 1 means 1. That is equation number 3. We can write at last from 2 and 3. From 2 and 3, what we can say, f of x is differentiable at x is equal to a, and this a be a any arbitrary constant. Okay, that remember. So you got both are ones, so that it is a continuous differentiable. Okay, you all understood anything? Any doubt in this? Yes, Priyanshi, it is equal. RHD is equal to 1. So that is about equation first one. Second, third. Okay, second also I'll explain. Then third and fourth to do as a homework. Okay. So now we go for second. So what is there in the second one? Second one, it is again, it is one of the easy. Third also easiest one, that is just e power x given. And next one sin x, and that is also easy one. So in this B, so now we are going to discuss B in this. That is second one. Constant function f of x is equal to c. Very nice question. So now here f of x is equal to c. C is a constant. Now for this also we have to find out. How can we find now in this? So it is a terrible one, but we'll try to find out how the answer is going to be. Okay. So you can understand that and how to find that is. Okay. So now first at x is equal to a we will find. So f of a is equal to here anywhere possible to keep substitution. Any x is there. If x is there, we will substitute. Otherwise, not possible to substitute. So we can write here as c. So f of a is equal to c. Right, Priyanshi already. Yes, it is correct. Okay, so now we will understand this now. LHD limit h tends to 0. I'm not writing this formula, directly writing answer. F of a minus h. So now a minus h place, we are not able to substitute a minus h. So c only is there. As it is c only you can write because there is no x. So only c is there. Only c we have to write. Minus f of a means again that is c upon a minus h. C minus C 0, 0 upon any number 0. That's what here 0. Same method RHD is equal to limit h tends to 0. C minus C upon h, that is nothing but 0. Clear? So then both LHD and RHD are 0. Therefore it is differentiable. Okay. So now third and fourth do as a homework. If you are having any doubt, that time you can ask me. So now we are going to the second one. So little fastly we have to go. Then only we'll complete today itself this. Right. Second one. Okay. Second question. Show that the following the function f of x is equal to modulus x is not differentiable at x is equal to 0. Very simple. It's not a big issue. It is very simple. So now here first f of 0. If you find 0 modulus of 0, that is nothing but 0. Now limit h tends to 0. This is your LHD. F of a minus h. A means what is here? At x is equal to 0 set, so that's 0. So now 0 minus h minus f of 0 upon minus h. Then f of minus h means what we can write here. Wherever x is there, we need to write minus h. So that modulus minus h minus f of 0 means here 0 upon modulus of minus h. So modulus of minus h is nothing but plus h. H minus 0, h. H upon minus h. Both get cancelled, you get us minus 1. This is limit h tends to 0. Here also limit h tends to 0. Then limit h tends to 0, minus 1 is nothing but minus 1. So this is equation number, will give us 2 because this is equation number 1. Now RHD. So we can write f of 0 plus h minus f of 0 upon plus h. Here limit h tends to 0. Here not equal. Okay, so limit h tends to 0. Now, f of 0 plus h means h. Modulus of h is nothing but h minus f of 0, 0 upon h. So, limit h tends to 0. H upon h is nothing but it is limit h tends to 0, 1. So, that is nothing but 1. Equation number 3. 2 is non-differentiable at x is equal to 0. All right, hence it is proved. Right. So you all understood this? Any doubt in this place? So here LHD is not equal to RHD, because of that we got. All right. So that is about your problem number 2, and now we are going to the problem number 3. It's very easy. Only simple. You have to remember LHD and RHD. If you remember that, it is possible to complete fastly. Otherwise, it is going to be difficult. Right. So that is about that. Now we are going to the third one. So now third question, listen. So here examine for the differentiability of a function f of x is equal to modulus of x minus 1 plus modulus of x at x is equal to 0 comma 1. Means first you need to find for at x is equal to 0, next you need to find for at x is equal to 1. Very good. I think Priyanshi, I thought I want to reduce my problems, but I found here it is 13 members, means still 5 members are missed. So 5 members are missed. Because of that reason, I could not accept your request and I could not able to complete early. If you are now also again, I am giving chance to you all. If you all properly is there minimum at least 5 minutes before itself, I can send you all 5 or 10. Okay, careful. So if you are continuously is there, it is possible for you all. Okay. See, that's what I said. Unity is strength. So so you all more unity in some other works, right? So kindly in this also be unity, be united. Okay. All right. Now we'll go for our third. Jidisha, I'll think about your comment. Okay. Then I may help you. Right. This is about your third question. What you need to do? Listen. Okay. I'll accept you all and okay, we'll complete. If next question completed, I will leave you all. Okay. You can say your present and that who are Janisha, you can take care, and Shubham, you also check whether all students are came or not. All right, now it is at x is equal to 0 first. So then first f of 0 is equal to, just substitute wherever x is there 0. So modulus of 0 minus 1 plus modulus of 0, that is equal to minus 1 modulus plus 0. Minus 1 modulus is nothing but plus 1. 1 plus 0 is nothing but 1. In this way, f of 0 you got as 1. Okay. So understand again, here wherever x is there, substitute 0. So then 0 minus 1 minus 1. Then minus 1 in the modulus becomes as plus 1. And here modulus 0 is nothing but 0. 1 plus 0 is nothing but 1. Okay. So now we'll go for LHD. That is equal to modulus of, so limit h tends to 0, f of a minus h minus f of a means here 0. 0 minus h, f of 0 upon minus h. F of 0 minus h means minus h. Wherever x is there, substitute minus h now. So get your answer. So now limit h tends to 0. So now here x plus minus h minus 1 modulus, and next one plus minus h. Then here minus symbol minus f of 0 means you got answer as 1. Just write 1 minus h. So now simplify here, minus common. When you common minus of h plus 1. When you have minus symbol for single term, then we can write it as a plus. So now we can write limit h tends to 0. So minus of modulus h plus 1 is nothing but h plus 1. Here minus h modulus is nothing but plus h upon minus h. And here it is minus 1 is there, write that minus 1. So now minus 1 plus 1 get cancelled. So what you are going to get here? So this is equal to limit h tends to 0, 2h upon minus h. H get cancelled. So limit h tends to 0 minus 2. So you got answer as here minus 2. So LHD you got as minus 2. Now you need to go for RHD. Okay. So when you go for RHD, what we are going to get? So RHD is equal to limit h tends to 0, f of 0 plus h minus f of 0 upon plus h. So 0 plus h means h. So you have to substitute here h, then get your answer. So you can write here modulus of h minus 1 plus modulus of h minus f of 0 means already you know as 1 upon h. Limit h tends to 0. This is equal to h minus 1 means h minus 1 only, because here there is no common possible also. So that we can write as h minus 1. So right here h minus 1 h, again here minus 1. So write that minus 1 upon h. Here limit h tends to 0. So now we can write this is equal to limit h tends to 0. H plus h, 2h, minus 1 minus 2 upon h. So now limit h tends to 0. In both common 2, then you get as h minus 1 upon h. So any other is left in this place? Right. H plus h, 2h upon minus 2 upon h. Okay. So now directly substitute here h plus is equal to 0. Then what you are going to get? Let me check here. Any possibility is there to cancel? Here common h. What we are going to do? Limit h tends to 0. H also common, 2h. 1 minus 1 upon h upon h. H get cancelled. Then we'll solve our problem. Where I can solve this part, I'll rub. Okay. Here just h common, and then this becomes as 1 and this becomes 1 upon h. So now what you got at last, that is equal to limit h tends to 0, 2 into 1 minus 1 upon h upon nothing is there. So upon nothing is there in this. So now here h tends to 0, remove this limit, wherever h is there, substitute 0. So 2 into 1 minus 1 upon 0. 1 upon 0 is nothing but what? It is going to be infinite. So now that is 2 into 1 minus infinite, that is nothing but infinite only. So we can say that it is not differentiable at x is equal to 0. So let me check this part. So we can say it is not differentiable. Here you got as infinite. Here anyhow, you know that according to our conditions, any one left hand derivative or right hand derivative, any one is infinite. We can say that it is completely is infinite. So 0 I found means it is completely not differentiable. Okay. So now here we found this is, anyhow I'll write here, otherwise it should not be good. It is equation number 2 and this equation number 3. You can write 2 is not equal to 3. Therefore it is not differentiable. Okay. Same method, at x is equal to 1, you try to find out and then we'll check. Okay. L, what is that? H, what? What is that? I can't understand H. Kirtan, what is that? So it is not differentiable at x is equal to 0. Yes, Priyanshi, it is correct. So that is about your third one. And at x is equal to 1, you find out. And now I'll go for our last problem for today, that is fourth one. Okay. If everyone is present for this, otherwise full class I'll take. And regularly, who are those people definitely going to get the benefit in their concept. So you don't worry. Who are coming regularly, they are going to get definitely benefit in the project works and all those marks and everywhere. So who are not attending to the classes, for them, theirs it was a different. Okay, don't worry about that. Yes, sir. Let's go, Shubham. Okay. All right. So now fourth one, examine the function differentiability at interval 0, comma 2. If f of x is equal to modulus of x minus 1 plus modulus of x minus 2. And before going to this, I need to explain to you this because previous year examination question and this year examination also, they were given this kind of questions as 6 mark. So I may tell one example for you. That kind they given for you all 6 mark question. That is your 12th question. Example number 12. Same kind question they were given as a 6 mark. Okay. So you be concentrate in these modulus problems. So now we can, here it is closed interval 0, comma 2 they given. That means you need to check for 0, 1, 2. Okay, so for 0, 1, 2 you have to check. So if it is differentiable at 0 or differentiable at 1, differentiable at 2, then only we can say that this whole function is differentiable at the closed interval 0, comma 2. If one place it is not differentiable, then we can say that it is not at all differentiable. Means, for example, at 0 it is differentiable and 1 not differentiable, 2 not differentiable. Then answer is not differentiable at interval 0, comma 2. So then all are different. So previous last one for today I said, right? Okay, at x is equal to 0. First one, and x is equal to 0. So first f of 0, wherever x is there, substitute 0. Modulus of 0 minus 1 plus, then modulus of 0 minus 2, you get as minus 1 modulus plus minus 2 modulus, that is 1 plus 2 is nothing but 3. Cleared up to here? F of 0 understood, I think. So now we'll go for LHD. LHD is equal to limit h tends to 0. Here x is 0, so that here also substitute 0. So f of 0 minus h. Wherever x is there, substitute minus h now. So when you substitute that, limit h tends to 0, minus h minus 1, then 2. Minus f of 0 means what do you know here? 3. Just substitute the 3 upon minus h. That is equal to limit h tends to 0. Minus common, then you get answer as minus of h plus 1. Modulus of minus of h plus 1 is nothing but h plus 1. Same method, minus of modulus h plus 2 is nothing but h plus 2. Here minus 3, as it is minus 3 upon minus h. So that is equal to limit h tends to 0. H plus h, 2h. 1 plus 2, 3. And here minus 3 upon minus h. Both get cancelled. This is equal to limit h tends to 0. 2h upon minus h. H get cancelled. That is limit h tends to 0 minus 2. That is nothing but minus 2. Equation number 2. So your LHD you got as minus 2. Now we'll go for RHD. F of 0 plus h minus f of 0 upon plus h. That is equal to, just substitute h in this equation. So now modulus of h plus h minus 1 plus h minus 2. And here you can write this as limit h tends to 0. Symbol here minus, and f of 0 is nothing but 3 upon h. Then just simplify it, what you get? You know that here no changes because limit h tends to 0, h plus h 2h minus 1, and here again minus 3 upon h. So now we can get here it is limit h tends to 0, and here it is 2h minus 6 upon h. 2h minus 6, 2h upon h. So now what we can write in this place? So limit h tends to 0 to 1h, that is equal to 6 upon h, that is upon h we can write h get cancelled. Then substitute now h is equal to 0. Then what you are going to get? So when you subtract limit h tends to 0 to minus 6 upon 0. 6 upon 0 means infinite. 2 minus infinite is nothing but infinite. The answer is here infinite you are going to get. So here this infinite and this was here minus 2. So any one is it is undefined, then we can say that it is a not differentiable. See, at x is equal to 0 only it is not differentiable. It is not at all possible to do for 1 and 2 not required. Directly we can say that. So this function is f of x is not differentiable at closed interval 0 comma 2 completes. Understood now? In that way you have at x is equal to 0. If you want again here, right, we can write in this place. Therefore, at closed interval 0 comma 2. Clear? So in that way you have to solve this, and if you have any doubts you can ask me right now. Anyone having any doubt here? 4 only is there? Who are that 4? Just say present. Just say now present, sir, so that I can understand who are there, who are not there. Who are present, say that I am present, sir. Lagging a lot. Why it is lagging for you all? Okay, no doubt it is. Anyone having any doubt? Jinisha said no doubt. Okay. No doubt, sir. Priyanshi. Okay. All right. So that is about that. Actually, this full exercise also. First LHD and RHD you have to take. In both you have to substitute. And if both are equal, then you have to say that it is differentiable, otherwise it is not differentiable. Any one is undefined or infinite, if you get, then we can say that it is not at all differentiable. Okay. Wait for some comment. Now getting. Now listen, your good news is this, and tomorrow, day after tomorrow, you have holiday. So tomorrow is for Sunday. So now I wish you all right. May God bless you all. Problem.